Hey everyone, my name is Joris Peels, and this is another episode of 3D Printing News Unpeeled. Today, we look at a partnership with IndoMIM. We look at a new way of scanning 3D printed objects and, well, some other stuff. Okay, so first off, let's look at IndoMIM. IndoMIM has been a very important company in 3D printing. So we all know that binder jet is a immensely popular technology at the moment, which doesn't have a lot of traction, but has a lot of hype and excitement around it and a lot of potential. Binder jet, of course, a different way using inkjet heads to join metal, if you will, and then later on to sinter and debind it in a separate process. And it proves to be a quite inexpensive way of doing 3D printing. Now, compared to powder bed fusion, it doesn't have all the part qualities that maybe powder bed fusion has, but it can do a lot on the throughput front and the lower cost powders and stuff like that to make the technology really accessible. Now, a really proponent of the technology has been IndoMIM, which is a large leading company in MIM technology. And MIM, they have exactly the same challenges in that sintering and debinding. So getting people that are good at that are really, really good. So what they've done now is they have acquired three Metal Jet S100 printers from HP. Two of them are printing in India, which is great, of course, for Indian industry and Indian high-tech industry, manufacturing industry and stuff. And the other one is at an IndoMIM site in Texas. So this is just not a fly-by-night partnership. It seems like they're deepening their relationship, and it seems like they're going to be doing lots of stuff in the future. This is a big win for HP as well because of just IndoMIM sintering and debinding expertise and the fact that they're going to act as a service for this. Previously IndoMIM bought a bound filament company. They've also had partnerships with Desktop Metal. So this is a big thing for HP to, kind of grow the credence, the inevitability of their technology. Now, I must say, of course, that, binder jet is an interesting technology, but it's difficult to qualify new parts. So if you're like a service bureau and people are pitching all sorts of new geometries to you every day, binder jet would suck. But if you're doing MRO for like a company like Shell or something, you're going to go through the trouble of qualifying 300 parts to work for binder jet from your 30 million parts and print them out in Nigeria and the Netherlands and the UK and all sorts of other places, then binder jet could be a wonderful technology. And if you're like a company like Cobra Golf and you want to just really qualify a few sizes and keep making those in a repetitive kind of way, with some variations perhaps, then also it'd be a really, really great technology. So this is not going to broadly replace a lot of stuff, but it is going to make a lot more new stuff possible, serial manufacturing of certain components of certain sizes, and perhaps even serial manufacturing quite small, quite intricate components as well. As we go on. So it's an interesting space to watch, but it's not, the be all end all of the technology because powder bed fusion will also have a role. Also indirect methods, like, wax printing and then casting will also have a role as well, depending on the use case and the cost and all that kind of thing. The next thing is a paper in the, well, I'm sure you read it every day, Waves in Random and Complex Media. That was done by Professor Anthony Mulholland of the School of Engineering, Maths and Technology at Bristol University. Now, this paper is looking at laser-based ultrasonic arrays, and they found a way to essentially use a mathematical model that looks at how these waves propagate through layered objects, metal layered objects. And they're looking at this as a way to perhaps make a scanner that uses laser ultrasonic kind of scanning methodology and the model to scan 3D printed parts. That would be wonderful. Now, if we're looking at powder bed fusion parts, for example, metallic parts, we always have problems with occlusions, holes, breaks in the part, either in the printing step, because some problems propagate, or some particles are the wrong shape or something like that, or we just have the laser doing something weird. There's also lots of different reasons where we can get holes and kind of breaks and problems in our part. Now, of course, if we're going to try and make this into a bracket for an aircraft, this is a problem. Up until now, we've got CT scanning. CT scanning is great. It's the same scan you do when you go to the doctor. But maybe this will prove to be a easier technology to scan all the layers and to scan the part maybe much quicker or in a much more detailed way. So anyways, it's good to see any kind of competition with 3D scanning or CT scanning, and any kind of competition that would maybe give us like a more holistic, faster way to get parts. I still maintain that I think that if we are looking at critical applications, we're going to have to 3D scan every single part to get the outside dimensions and the roughness and all this kind of stuff. And we're going to also have to scan each part from the inside in some way. Other people think we can do this with statistical methods, but I think that there's too much variability across the print bed and too much run-to-run differences in machines and too much going on essentially that we don't understand for us to really kind of rely on statistical methods. Now, because of that, something like that is super welcome. We don't know how close it is to becoming an actual technology, but it's nice that people are working on different ways to look inside parts, because that's been a big problem for us going forward. The work is by Mr. Ferguson, the Mr. Tant, Fondun, and Mulholland, or Mrs. I think Tant, and then Fundun and Mulholland. Available in waves in random and complex media, and it's called A Probabilistic Approach to Modeling Ultrasonic Shear Wave Propagation in Locally Anisotropic Heterogeneous Media. It's a bit of a brain breaker. It made my head melt a little bit, and I didn't get through most of it. But the part I did get through was, I don't know, it's very exciting, actually. But it's not like reading. Let's put it that way, or at least it wasn't for me. Maybe it will be for you. And the next news is from Orbex. Orbex is a UK-based space company. I think it has a spaceport in Sutherland. And they've just recently gotten 16 million pounds, 16.7 million pounds, which is about 19 million euros, like 21 million US, something like that. Orbex is a company, Orbex Space. Actually, they do a 2-stage rocket that is supposed to be like low carbon fuel, things like that. And it's supposed to deploy small satellites in low Earth orbit. Now, why is this important? Because, well, low Earth orbit is kind of like the low-hanging fruit, if you will, of the orbit kind of technology. But also, we expect that through these lithography processes, through machines like the EUV machine from ASML, and just generally Moore's law and all these things, that we will see a continued miniaturization and acceleration, or a continued sustained improvement to the processing power of computers, and of also in other lithographic processes, the efficiency of things like solar panels and other kind of processors and controllers and things like that. And because of that, we can expect that today's medium satellites will be superseded by mini satellites, pico or nano satellites, having the same abilities in future years. Now, we of course don't know if this Moore's law stuff is forever, but assuming that it will continue to go on for another couple of decades, assuming that the launch market is as hot as people think, and that it'll grow with thousands of percent, and assuming that there's all sorts of startups that are going to be selling, like, I don't know, accurate rain data for farmers, or some company will come up with an array that collects agricultural data, and then another company on top of it will sell that data to wine growers and tell them what the best day to pick their grapes in Bordeaux is, or something like that. So assuming that ecosystem, this layered ecosystem, so you've got launch companies like Orbex and SpaceX, you've got satellite builders, then you've got array operating companies that operate these satellites, and then we've got all sorts of technology companies in between, and then we have a layer of companies that do the content or the curation of content on top of that. Now, if that ecosystem continues to develop, we would expect a really ultra healthy satellite space. And Orbex is an alternative. It's a European, depending on how you look at it, as in located in Europe alternative. Now, that's significant, because imagine there is some kind of event in the United States of America that means that there's more regulation for satellites, or there's more regulation for space, or there's different kind of taxation or something like that. There's not a lot of alternatives at the moment in launch places. So Sutherland, where these guys have their spaceport, might be a very important thing. Maybe there's some kind of weather event across certain areas of the United States of America, a storm in the Florida coast at the same time as an earthquake, or the same kind of area or months, would really completely destabilize the entire space ecosystem. Just like earthquake in California, which we know happened, and a storm in Florida, which we know happens, would really wreak havoc. So having any kind of alternative ecosystem, wherever it is on the Earth, is really good. And Orbex is really charging ahead. Now, they've gotten, I think, it's about 40, 50 million. That's a lot of money. But in the space, that's not a lot of money at all. There are companies raising hundreds and hundreds of millions. There's companies that have burn rates of several million a day sometimes. There's companies getting multi-billion-dollar contracts. So it's not a lot, right? Even though it would be a lot if they were making, like, I don't know, wheelchairs or something like that, right? Or like, some kind of more projecting. But in space, that's not a lot of money. So Orbex is doing walking a fine line here, because they're UK based. They're not in the European Union at the moment. So at the moment, our Airbus and a bunch of other companies are going to get together and come up with a serious competitor of theirs. It hasn't happened so far, right? Or is the future of European commercial space going to be in the UK? And that could be a huge win for the United Kingdom, to be that relevant and to maintain that technological infrastructure, all these engineering jobs. This is a big deal, because if they become the default geographical European launch provider, or the biggest, and they don't have really serious competition, well, then America is going to be the de facto regulator for space, Europe will have a small little thing to say, and the European Union and stuff will have basically nothing except for the old Ariana kind of system that they had before. So this could be like this is a startup with like geopolitical um, implications, and also if they just have, imagine you can work in space, and all of a sudden you can't get a visa to the United States of America, for example. Where are you going to work? Right? There's the European Space Agency, of course. There's some Airbus Space and Defense, that kind of thing. There's very few places that you can work if you want to be a part of this revolution, but if you have a EU passport but on an American green card. So that could really suck up a ton of talent and a ton of really, really good people into this thing. So Orbex it's a really important thing. And again, 40 million is not a lot, but they're doing a lot better than anyone else's and launch things in Europe. So these guys, we're watching them really closely because they use AMCM machines. Those are custom-made machines from EOS. If you want a really large copper machine or something that's not available from EOS or EOS came out, then you can buy, or the AMCM will kind of basically customize a machine for you. They also big user SLM solution machines. So there's another kind of company using 3D printing to get into space, and that's a big deal as well. So that was the news for today. My name is Joris Peels, and this is another edition of 3D Printing News Unpeeled. Please let us know if this is useful to you, and you have